On this problem number 15, we have a toy rocket that is shot vertically into the air from a launching pad 7 feet above the ground with an initial velocity of 104 feet per second. Then it gives me the function h of t equals negative 16 t squared plus 104t plus 7, where t is going to be the number of seconds that it takes the rocket to reach its maximum height, and h of t will be the actual maximum height that the rocket reaches. Now, think about this. If you are a toy or a kid shooting off a toy rocket, here's what's going to happen. It's going to shoot up into the air until it reaches its maximum height, and then it's going to fall back down to the ground. So what we need to do is find that point where it reaches its maximum height. So you'll notice that that's going to be the vertex of that upside down parabola that is given to us by the function that we see. So I'm going to find the vertex by using the opposite of b over 2a. If b is 104, the opposite of it is negative 104. 2 times a, my a is negative 16. So now I have negative 104 over negative 32, and I'll just put that in my calculator. Negative 104 divided by negative 32, and it tells me 3.25. So now I know that the first point of that vertex is 3.25. And to find the second point, I'm just going to replace the t's in this function with that 3.25. So I've got negative 16, open parenthesis, 3.25, close. Then I'll square that, plus 104, open parenthesis, 3.25, close, plus 7, which gives me 176. So that's the second point, or second part of the vertex. So the number of seconds would be the 3.25, and then the maximum height that the rocket reaches would be 176. All right, this next problem, we're going to determine the domain of a square root function. So if my function is f of x equals the square root of 2x plus 3, and I need to know what can those x's be, or what is the domain. When you're looking for the domain of a square root function, the radicand, which is what's underneath that square root symbol, cannot be negative, which means whatever that radicand is, which in this case is 2x plus 3, it needs to be greater than or equal to 0. And then solve it for the x. So subtract the 3's from both sides. So 2x needs to be greater than or equal to negative 3, and then divide by 2. So x needs to be greater than or equal to negative 3/2. All right, on the next question, I have graphed the function f of x equals 15, or excuse me, the square root of 15 plus 3x. I'm going to put that in my y equals. So second square root 15 plus 3x, and graph that. So it's going to have that square root function, and you'll notice where it's starting to the left, 3, 4, 5. So it starts here and then goes up and to the right. When we are looking at these, There's actually only one that has the correct shape. Let's just look at it. So you'll notice when we're talking about starting to the left 5, notice where your origin is, and it looks like it just goes to the left 2.5. But you'll notice that the scale of that x-axis, all of the lines are going by 2s. So that going to the left 2.5 is actually matching going to the right 5. All right, on this next problem, it's going to give us the function and ask us where it's increasing, constant, and decreasing. Okay, and remember, you read like a book. What I'm going to do now is go through and label what's happening on each interval. When I come in from the left, the first part I'm going to run into is this very left part of the graph where the values are going down. So that'll be a decrease. And then the next part, when it's horizontal, that's your constant. And then once it reaches a certain point, then it goes up, and that's your increase. Now, after I label what is happening on each part, the next thing I'm going to do is go through to those 2 points where there's a change in direction, like in between the decrease and the constant, that 1 point, and I'm going to label its x coordinate. So it is lined up with -2 on the x, and then I'll go to the next change in direction and label its x, which is +2. And then I can do my intervals. So the first one, talking about where it's increasing, is going to be talking about this interval here. So you'll notice that it's increasing starting at 2 until infinity. Everybody gets parentheses when you're talking about increasing. The next part wants to know where it's constant. Well, it's constant in that middle part, so it starts being constant at -2, and it stays constant until it gets to +2. And the last part wants to know where it's decreasing. So it starts decreasing all the way from the left side at -infinity until it gets to -2. On the next problem, I'm going to do the same thing since it's asking me the same questions, talking about increasing, decreasing, and constant, coming in from the left side, starting at -infinity. I'll run into the graph on the left side, and the values are going up, so that'll be an increase until I get to that turning point, and then they'll go down. So there's a decrease until I get to the next turning point where they're going horizontal, so that's your constant. And then the values start going up again, so there's another increase until they get to the next change in direction, and then they'll be constant again. Now, I'm going to go through each change of direction and say what the x coordinate is there. So this first change in direction would be here. So it's lined up with the x of -6. Then there's the next change of direction. Its x is -4. Next change of direction, its x is -1. This one, remember, you're using the x, not the y. That's lined up with the origin, so its x coordinate is 0. Now that I have it all written out, I can see my intervals. So the increase has 2 intervals. My first one starts at -infinity until it gets to -6. And then I've got another increase that starts at -1 until it gets to 0. Let's look at our decreasing. interval, which starts at -6 until it gets to -4. And then my last would be constant, which are the two intervals where it's horizontal. My first one would be from -4 to -1. And then there's another constant interval that starts at 0 and goes forever to the right. So from 0 to infinity. All right, this next problem is talking about relative maximum and minimum. The relative maximum is going to come from that point that's at the top of that hill. So that point, which is at -4, -1. So the maximum is going to be what the y coordinate is. So the maximum is going to be at -1. And where it occurs is the x coordinate. So this is going to occur at x equals -4. The relative minimum is the point that's at the bottom of that valley, which is at 2, -19. So the minimum value, again, that's the y, so it's -19, and it occurs at x equals 2. Then it wants to know where this is increasing. And remember, we're talking about increasing and decreasing like we're reading a book. So we're coming in from the left. And we are going to be increasing all the way from -infinity until we get to this point, and then we use its x coordinate. So the increase, that increasing interval, will be from -infinity to -4. And then it's going to go down for a little bit until it gets to this point, and then it's going to increase again. So that one's increase starts at 2 and goes to infinity. And the decrease, which will be this middle part right here. So it starts at -4 and it goes to positive 2. All right, this next one is also going to be talking about a relative maximum and a relative minimum. So the maximum is talking about this point here. So let's think about where that point is. What are the x and y coordinates of that point? Its x would be 0 and its y would be 1. So the maximum value is going to be 1, and it occurs at x equals 0. Here's where we're talking about the minimum. So let's name its ordered pair. Its x would be +2, and its y would be -3, which means its minimum value is -3, and it occurs at x equals 2. On this next problem, we are going to be talking about piecewise functions. So our function is g of x equals x plus 8 for when x is less than or equal to 1. And then it turns to 6 minus x for when x is greater than 1. So here's what I like to do. I like to draw my x-axis, and it's just a number line, and then put any number you see represented on this side. The only number I see is 1. So when you're less than or equal to 1, you're the x plus 8 piece. And if you're greater than the 1, then you're the 6 minus x piece. The first thing it wants me to find is g of -9. What that means is go find -9 on your number line, which would be on this side of the 1. Well, that tells you what piece you need to put your number in. So I am in the x plus 8 piece, and then I replace the x with that number. So I'll have -9 plus 8, which gives me -1. The next part wants me to find g of 1. When I go and I look at the number line and find the 1, that is actually the number that separates my x-axis into the two separate pieces. So I need to come up to my function and see where it says x equals 1. So you'll notice that is in the first part. So this is also going in the x plus 8, and then I'll replace that x with 1. So I have 1 plus 8, which gives me 9. And then the last part wants me to find g of 6. So I find 6 on the number line, which is going to be here on the right side of 1. So now we are in the 6 minus x piece, and then, replace your x with that 6. So you'll have 6 minus 6, which gives me 0. All right, this next problem is another piecewise function. Our function is h of x equals -2x minus 14 for when x is less than -4. It's 3 for -4 less than or equal to x, which is less than 3, and it's x plus 8 for when x is greater than or equal to 3. So again, I'm going to draw out my number line. This time there's 3 separate pieces. The numbers that are separating your 3 pieces are the -4 and 3. So my first piece is the -2x minus 14. My second piece is just 3, and my last piece is x plus 8. And it wants me to find those 4 function values. So the first one is h of -6. So just like the last one, I find where -6 would be on the number line, and it's in that first piece, so it's in -2x minus 14, and then put your -6 in for the x. So I'll have -2 times -6 minus 14, which gives me 12, minus 14, which is -2. Then it wants me to find h of 2. So where would that be on this number line? h2 would be in that middle piece. If that is the case, look what you're plugging into. You're just a 3. You don't even have anything to plug into. When you're between the -4 and the 3, then your answer is just 3. And then h of 3, you'll notice that 3 is one of the numbers that's breaking up the number line. So you're looking for where x equals 3. So that's in that last piece of x plus 8. Replace your x with the 3. So you have 3 plus 8, which gives you 11. And then the last one, h of 4. So 4 is on this side of 3. So it's also in the x plus 8 piece, and then replace it. So I've got 4 plus 8, which gives me 12. All right, the last problems on the quiz are going to be working with the difference quotient, which is f of x plus h minus f of x all over h. The first function that we are going to construct and simplify the difference quotient is f of x equals -6x plus 1. So your first step is to simply, you're going to rewrite this function and replace that x with an x plus h. So you've got -6. Replace your x with x plus h. plus 1. The next part of the difference quotient is to subtract in parentheses exactly what the original function was, which is negative 6x plus 1. Now, we are going to simplify this. We'll worry about the denominator being h at the very end. I'm going to distribute the 6 here, or excuse me, negative 6, which gives me negative 6x minus 6h, bring down the plus 1, and then I'll distribute the negative to the second parentheses, which is just going to change those signs. So that's going to make that a positive 6x and a negative 1. And everything that you just distributed a negative to should cancel something. So that negative 1 cancels out the positive 1, and that positive 6x cancels out the negative 6x. So now you're just left with negative 6h. Now put in the denominator of your difference quotient, which is h. The h's cancel, so you are just left with negative 6. All right, last one, another difference quotient. So I'm going to, just like the last problem, rewrite my function, replacing the x's with x plus h's. So if I do that, I've got negative 8. Replace your x with x plus h squared. Plus 9. Replace that x with x plus h. Bring down the plus 8. Then the second part is to subtract in parentheses what the original function was. So negative 8x squared plus 9x plus 8. Now, before I can go any further, I've got to do this. X plus h squared. I'm going to do it down here, and then I'm just going to erase it. So x plus h squared means to multiply x plus h times itself. So I'm going to FOIL here. X times x gives me x squared. Plus x times h gives me xh. My inside is actually another xh, and then my last is plus h squared. So what I'm going to do next is put my xh's together. So I've got x squared plus, if you have one here and one here, you have two xh's plus h squared. So when you have to fill in for x plus h squared, that's what you're going to have. So you got negative 8, and then fill in x squared plus 2xh plus h squared. So now I'm going to erase that part where I did the foiling. So I can work the rest of the problem. So now I'll distribute my negative 8. So negative 8 times x squared gives me negative 8x squared. Negative 8 times positive 2 gives me negative 16xh. Negative 8 times positive h squared gives me negative 8h squared. Now, moving down, I'll distribute the 9 here. So that's going to give me a plus 9x plus 9h. Bring down my plus 8. Then the last part, I'm going to distribute this negative. When I distribute that negative, it's going to change all the signs. So that's going to end up being a plus 8x squared minus 9x minus 8. And once again, everything that you distributed a negative to should cancel something. So the negative 8 cancels out the positive 8. That negative 9x cancels out that positive 9x. That positive 8x squared cancels out that negative 8x squared. So now let's rewrite what's left, which is negative 16xh minus 8h squared plus 9h. And when you put in the denominator, which is h, what I notice is that every single term in the numerator has an h in common. So what you want to do is pull out that h and put in parentheses what is left. So if I take the h out of that first term, I have negative 16x. Minus, if I take an h out of this term, since it had an h squared, I still have minus 8h. Plus, if I take an h out of that last term, I'm just left with plus 9. Again, your denominator is the h, so now the h's cancel, and what you have left inside that parentheses is your final answer, negative 16x minus 8h plus 9.